Alrighty, so parent functions and transformations. So first of all, you've got to be familiar with the parent functions to even begin any of this. So make sure that you know quadratic, right? What a linear function looks like, cubic, etc. You got to know all that before you even can start to begin some of this. Okay, so make sure you go back and look at that. All right, but transformations. Let's talk about the different types of transformations that we have. So this is each different type. Okay, and we're kind of looking at the function notation, right? This is like our function notation, f of x, and we're kind of looking at what we're doing at each step here. So let's go ahead and start with the descriptions. Okay, so when we are adding k, now actually before we start, let's go ahead and talk about what each one is. Okay, we've got a, we've got h, and we've got k. And we also have C. Okay, now you may see like A, H, and K are pretty standard. You're going to see that everywhere. But with the C, it may be a little bit different. So keep in mind, sometimes you'll see this as B, but I'm going to go with C. Okay, so we've got f of x, and we are adding a value. Okay, now when we add a value outside of the function, okay, now notice this is outside the function, and we'll get into what exactly I mean by outside of the function later. But what this is, when it's outside of the function, you're going to be having a vertical shift. Okay? Now, if it's a positive k, it's going to be up. And if it is a negative k, it is going to be down. Okay? That's a vertical shift. You're literally taking that function, you are shifting it up and down. Okay? This one right here. Now, this is a horizontal shift. Okay? Now notice the main difference between what these look like. Okay, I am actually inside the function here. Okay, now a lot of times that'll be like using parentheses. It is directly next to x. So if you look at x in our function, it is right there. Okay, so wherever, like if we are directly next to x, I'm going to go ahead and show you an example just while I'm at it. Right here. Okay, so notice this is like inside the parentheses, directly next to that x, we are subtracting 3, so that would be an example of a horizontal shift. Okay, anyways, horizontal shift, okay, if I have a positive h, I am going to the right. Now this may seem a little backwards, but bear with me here. Negative h, we are going to the left. Okay, now let's talk about this. Notice when I was working with k, I was adding k, and if I went up, you know, positive number goes up, makes sense. Okay, but over here I've got a x minus h. Okay, now if I have a positive value for my h, let's say it's x minus 2, we're actually going to be shifting to the right. So it's a little bit backwards, okay, and you have to kind of think about that however works best with you. But if I have a positive h, right, if let's say my h is 2, it would look like x minus 2, right? I'm literally replacing that h with that value. If that's the case, we would have a shift to the right by 2. Okay, and then negative, but think about what a negative would look like. Let's think about the example of negative 3. Okay, so let's say my h is negative 3. Okay, if I'm in here, I've got x minus negative 3, right? So this would end up being a plus, which would mean we would go to the left. Okay, there's those. All right, so multiplying a value outside the function, okay, this is a vertical stretch. All right, by a factor of a. Okay, by a factor of a. All right, so, you know, let's say it's 2, right? I'm stretching by a factor of a. I'm stretching my y value by a factor of a. Okay, because it's vertical. Okay, what happens when it's a negative on the outside, though? Now, notice this is actually part of your a. Okay, I do want to point that out. It is actually part of your a. You'll see it outside that function. Okay, not inside the function. Right, inside is with the parentheses. Outside is outside the entire f of x function part. Okay, but again, this is a part of a. And when it's a negative, you're actually going to have a reflection. Since it's outside the function, I have a vertical reflection. Okay, and in other words, we are reflecting, if we're going to be reflecting vertically, we've got to think about what axis we are reflecting across. Well, in this case, we're going to be reflecting across the x-axis. All right, and again, we'll look at examples. We're going to look at how this works later, but we need to kind of establish the rules first. Okay, this one right here. Okay, this is, notice negative, negative, but look at the big difference, right? This is inside the function. Okay, this is directly next to x. Okay, we are multiplying -1 times my x. This is outside the function. Okay, we'll look at specifics with that and kind of talk about the differences later. Okay, but with the negative here, similarly, okay, you can kind of compare them. As opposed to a vertical reflection, though, we're going to have a horizontal reflection. Okay, and therefore we'll reflect across, this time, the y-axis. Okay, on this next one, f of c of x. Okay, f of c of x. Okay, very similar to what we did up here, right? We are multiplying something, right? We're multiplying something, but this is on the outside, this is on the inside of the function. Okay, this is going to get us a horizontal stretch by a factor of, now note the difference, okay? We had a stretch by a factor of a here, okay? It is not just a horizontal stretch by a factor of c, okay? This is actually going to be a horizontal stretch by a factor of 1 over c, okay? We could get into why, but for now, you know, with the exploration comes this sort of learning as to why this is the case. And you can try it on Desmos, okay? And the best way to do it would honestly be using a table. If you look at the tables of all these functions, you will see why when you multiply something in here, it actually stretches it by a factor of 1 over c, okay? Which kind of means it compresses it in a way. Another way to think about this would be a horizontal compression by a factor of c, okay? Just c. So, but we like to be consistent, okay? We want to say horizontal stretch by a factor of 1 over c, but you can also think about it that other way. Okay, so probably, in my opinion, kind of the two most confusing are going to be these two, okay, because they're backwards, okay? It's a little bit flipped than what we would normally think as the function relates, okay? So what ends up happening is a little bit backwards in those two cases, okay? All right, so let's look at a few of these, maybe one or two of the kind of what we call like move the monster. It's just looking at the function, right? You have this function, okay? The function is graph below, so you have this like funky looking shape, okay? We're going to perform each transformation to them. So let's do the hard ones. Let's jump in and do the hard ones. Right here, let's go ahead and start with this one right here, okay? So we've got to identify what we have. The two differences, right? I'm starting at f of x. Okay, the two differences are we've got this little guy and this little guy. So we've got to think about what is actually going on there. Okay, so inside of this, we got to think about, is that my A, H, K, or C? Now what this would look like, let's just go ahead and write the whole like transformation thing. We got A on the outside. Okay, we've got times f of, well, x, no, actually C. C got to come first here. C, okay, and then times x minus h, there's actually a second parentheses, and then plus k. That's how you're going to see all those values. Okay, A is going to go out front, C is going to be multiplying x. Okay, x minus h is going to be directly inside those parentheses. Okay, we're subtracting here, and then we're adding k. So we've got to think about what we have. Well, this is a plus 1. It's inside the parentheses. Notice I'm not multiplying anything by x, so I don't have a c. I don't have an a. Okay, so I've got an h and a k here. So my h, okay, is actually going to be equal to -1. I know there's a plus 1 here, but that's what I'm talking about with that backwards mentality, right? So we've got x minus -1, right? Which means I end up having an x plus 1. Okay, and then on the very outside I've got -3. Okay, so my k is also negative, -3. okay? All right, so we've got to think about what these represent. Well, I've got an H, okay? So H is a horizontal shift. If my H is negative, okay, I'm going to the left. So I'm just going to go ahead and shift each point 1, okay? So we kind of want to do them both at the same time. It's going to make our lives a little bit easier. But with our K, we have a negative K, and we're going down. So I've got left 1, okay, left 1, and then down 3. So that's my new point right there. Okay, maybe that's a little bit hard to see. All right, but that is my new point right there. Okay, and then over here, right, same thing. I'm going to do that for each point, and I'm just going to connect the dots. Okay, so I've got over 1, down 3. Okay, same here, over 1, down 3, over 1 to the left, down 3, over 1 to the left, down 3, and then we connect. Okay, now notice it's the exact same kind of shape. It's just shifted, okay? It's shifted from that original over 1 down 3, okay? Let's look at another one. Let's look at one where we're doing a vertical stretch, maybe a reflection. Let's go ahead and do both of these, okay? Let's do both of these, and then we'll do on the back. Okay, so negative f of x, okay, notice it's on the outside, okay, it is on the outside of f of x, so I am reflecting across my x-axis here, okay, so just real quick, right, we're literally got to think about which one's my x, my y, and you just take those points, and you find that x-axis, and you reflect straight across. So this one looks like it's supposed to be like right here, okay. This one is right, let's see, 4, okay, so 4 here, all right, this one, you do nothing, right, because the reflection is already, or that point is already on the x-axis, you can't do anything. Here's this one, okay, and then here's this one. You got to connect the dots, okay. Some people get a little bit confused as to, as to where we should go from here, but we got to go back to that point. Remember, that point is actually my reflection, and then we are going to go down like that, and then like that. So that is my reflection vertical, okay, and it says to describe them, okay, so technically we didn't do that here, but this is a vertical reflection, okay, and then if we wanted to write it, horizontal reflection, or sorry, horizontal shift 1 to the left, and then vertical shift down by 3, okay. All right, let's compare these two, okay, because that's important to look at the difference, okay. So we're multiplying by 2 here. Okay, this is 2 vertical stretch by a factor of a. We use that factor. Okay, we're going to use that factor there. So we're multiplying whatever value your y value is by 2. Okay, so my y value here is negative 2. Okay, now notice we don't do anything with x. Like this point is still going to be along this line here somewhere. Okay, it's still going to be along that same x coordinate. Okay. So I have a negative 2 here. I'm multiplying that negative 2 by 2, so I still remain negative, okay? And so it's going to be at negative 4. On this one, okay, let's go ahead and zoom. Let's see a little bit better. Okay, on this one right here, we've got 4, okay? And again, my value of y there is 4. I need to multiply by 2. Okay, so what you got to think about if it's positive or negative, right? If it's negative, it's going to go further negative. If it's positive, it's going to go further positive. Okay, so I've got 4 times 2. There it is. Okay, 0 is my y value. What happens at 0? Well, 0 times 2 is still 0. So nothing happens here. We can't stretch it if it's already at 0. Okay, here we go with positive 5. We're multiplying it by 2. There we go. And then negative 5 here, multiplying it, going further negative. So this stretch would look like this. Okay, we are literally stretching it. Yes. Okay, literally I had a sign outside my door that said, "Don't come in," and someone come in. Hashtag remote learning life. Okay, I don't even remember where I was, but I guess we'll go ahead and do this one. Okay, so 1/2. Same exact thing, but we've got to now think about what my factor is, right? I'm now multiplying by 1/2, which is the same as divided by 2, right? So I've got to think about, I'm still applying this to my y. Let's go back here, sorry vertical stretch by 2, okay? Vertical stretch by 2. This is going to be the exact same thing, just vertical stretch by 1/2, okay? So I'm taking this value of 2, I'm going here, right? Because 2 divided by 2 is 1, okay? 4 divided by 2, 2. 0 divided by 2, still 0. 5 divided by 2, we've got to split it, 2.5, and then 2.5 down here this time. Okay, so there it is. Okay, and again, got to be consistent with positive, negative here. Okay, but that's the vertical stretch by 1/2. All right, to compare, okay, now we're looking at, well, this is inside the function, so this is a horizontal reflection. Okay, this is horizontal reflection just to show you, okay, real quick. We've got, positive 8 here, so now it's going to go across the y-axis, so it's now going to be negative 8. Okay, I'm not going to do the rest of those, okay, but I'm going to do these two up here. Okay, we've got 2x. Now this, let's just write it first. Okay, this is going to be a horizontal horizontal stretch by a factor of, well, let's look at our notes. Okay, if it's inside the function, horizontal stretch by a factor of 1 over c, whatever that c is. So it's now going to be a 1 over 2 factor here. Okay, so but it's horizontal. Okay, so now I'm changing my x value, but my y value stays the same. So let's go ahead and start with this one. I've got an x value of -6. That's what I'm splitting in half. So it's now going to be right here. But notice my y value remains the same. Okay, my y value remains the same. I've got 3, splitting it in 1/2. It goes here. Okay, on this one, okay, we haven't been changing that one very much, but on this one we do have to change it because we got to think about what my x value is here. Okay, so my x value is 3. I'm splitting that. It's 1/2 now. Okay, we've got 6 here. Now 3, and then we've got that 8. Splitting it, keeping the same y value, and there it is. Okay, so it is now horizontally stretched by a factor of 1/2. Okay, and just to show you, one way to think about this again would be a horizontal compression by 2. Okay, so different ways to think about it, right? But we'd like to be consistent. Keep it a horizontal stretch by a factor of 1/2. Okay, but it is also a horizontal compression by 2. Okay. Now, what the difference is here. Okay, this is now going to be a horizontal compression. Stretch. Horizontal stretch by 1 over 1/2. Okay, which ends up being 2. Okay, so it's a horizontal stretch by 2. So now I'm taking this, multiplying by 2. So it's going to go way out here. -6. It's going to be -12. Okay, we got 3. Now I'm going to 6. 3 here, again going to 6. 6 going to 12. And then this 8 going out to 16. So it's going to look something like this. Okay, and that is going to be your horizontal stretch by a factor of 1 over 1/2, which gets you 2. Okay, that's move the monster. All right, that's with just the f of x, okay, and all that. Now let's look at some, again, I'm going to try to do the hard examples of ones where we're actually looking at different various functions. Okay, so for each one, we're going to name the parent function, write the equation for the parent function, describe the transformation, all that stuff, okay? Let's go ahead and begin, all right? First of all, you've got to name that parent function, okay? Now, here's why you've got to be comfortable with parent functions. You need to identify what is the main factor, right? So you got to look, you got to be kind of a, investigator here, and you got to figure out what are we actually doing. What are we doing to x that's different besides just subtracting all that different stuff, okay? So we've got to think about our options. We've got quadratic, we've got logarithmic, we've got rational, all that different stuff. So on this particular one, though, we've got this right here, okay? So my parent function, okay, because of that squared, I'm not going to circle it, but because of that squared, okay, it is a quadratic function, Okay, so that's the identifier, right? That's what gives it away. Just to look at the other ones, right? I've got cubic here because of that. I've got absolute value here, okay? To even continue, okay, we've got 3 to the x. Okay, that's going to be exponential, okay, because of the dividing, rational, because of the square root, okay? So that's how you can identify. Those are some of the kind of things that give it away. Okay, so that's a quadratic function. It says B to write the equation of the parent function. Well, the parent function for quadratic is just x squared, right? It's just plain old simple x squared without all the other stuff, right? And here's the other stuff that we're doing, okay? Those are my transformations, okay? But if I take those things away, all I've got is x squared, all right? So there we have it, okay? Now we've got to identify what these transformations are, all right? So describe the transformations. Here we go. So this is on the outside. Okay, we're going to start one by one. This is on the outside here. Okay, and what I mean by the outside is I've got this stuff in parentheses. Okay, and it's outside of the parent function, that thing that we're doing, right? That what is the word I'm looking for? Well, that the special thing, right? The squared, the cubic, the absolute value, right? I'm just losing the word, but regardless. Okay, so we're on the outside here. That's how we know it is going to be a vertical stretch. Okay, it is going to be a vertical stretch here. All right. So first one, vertical stretch. Again, the reason I know is because it's on the outside. If it was directly next to x right here, if that 1/2 was directly next inside the parentheses, that's going to give me that horizontal stretch. Okay, but it's a vertical stretch by 1/2. Okay, next one. Okay, we can check that off. -3. Notice we're on the inside of the parentheses. Notice the difference, right? We've got the parentheses here. Okay, inside the operation. That's the word I was looking for. Operation. Inside the operation, I am subtracting 3. Okay, outside the operation, I'm adding 4. Okay, so inside the operation here, that means it's going to be a horizontal shift. Notice we're subtracting, right? Subtracting here. Okay, so horizontal shift. Okay, it's flipped though, right? Since we're subtracting 3, that means my h is equal to 3. So it's going to be a shift right 3. Okay, second one, +4. Okay, vertical shift. This is, I mean, most people with the K, right? This is a K value. Most people feel pretty comfortable with that. Usually it's pretty quick. Okay, so the vertical shift, boom, up 4. Okay. On D, sketch a graph of the transformed function. Okay. Always helpful to have both. Okay. So let's go ahead and write the parent function first. Okay. Now the parent function, okay, is your plain old, right, like at 0, 0. It's like at 1, 1. Okay, and it's at like 2, 4. Okay, so at -2, 4 as well. Those are some of the values. Okay, sometimes it helps to get those values around 0 to kind of get a real idea of what you're looking at. Okay, always start with this. Always start with the shifts. Okay, because you're shifting the function. Okay, you're shifting like that 0, 0 point. Okay, that's, in my opinion, the best way to start. You're always going to have like a center for the function. Okay, and the center is usually at that 0, 0. Okay, but for this particular one, you've got that center. You start there. And you got to think about where to go from there. Okay, so we're going to go 0, 0. We're going to go right 3. Okay, I'm just sketching, right? Right 3, up 4. Okay, so now it's here. All right, and we'll go ahead and do the blue one. Blue for the transformed function. Okay, so now my center is here. Okay, then I've got a vertical stretch by 1/2. Well, remember when we had 1, 1, or -1, 1, and then 1, 1. Well, now it's going to be a little smaller. Okay, so it's going to be like that. It's going to be a little hard to see, but again, we're just sketching. Okay, we're just sketching. All right, and then this is over -2, up 4, but now it's really going to be over -2, -2, or +2. Okay, so it's a little, we're stretching it by 1/2. In other words, we're compressing it. Okay, so that's going to be my function. It's going to be a little thicker, right? There it is. Okay, not perfect, but it's a sketch. Okay, the domain. All right, let's talk about the domain and the range. Okay, you can usually tell it by the transform function, so you can usually just go with this. So let's go and do domain. Domain doesn't change for this particular one. Okay, we probably haven't seen this yet, but this is x such that x is anything that's a real number. Okay, range y such that y, well, we've got to think about what we're doing here. Okay, no values below this point for y. Okay, so it actually starts at that value, and we've got to think about what that value is, right? Well, we shifted it over 3, and then we went up 4. Okay, so that's my starting point. It's got to be greater or equal to 4. Okay, so that's one example. All right, it's going to be the same process every time. Okay, you're going to have to just identify what you're doing to that parent function, and you shift or stretch or move the function or reflect it as needed. Okay, let's go ahead and do this last one here. Okay. All right, let's do this. Okay. So, identify the parent function. Okay, this is a square root. Okay. B, write the equation. This is f of x equals plain old square root of x. Okay, that's my normal operation. I can see it right there. C, okay, talk about the transformations. Okay, well, what's different from here to here? Okay, we've got the negative. Okay, we've got the -1 on the inside, and then we've got the +6 on the outside. Don't try to combine these. Okay, if you want, if it helps, put parentheses here. Okay, that kind of tells you what's on the inside and what's on the outside of the operation. Okay, it is super important to think about it in those terms. All right, with C, so we'll just start identifying. Well, this is on the outside of my operation. If it was in here, that'd be on the inside. Okay, this is on the outside of the operation, so that's going to be a vertical reflection. Okay, that's that. Moving on. -1. Okay, that's going to be a horizontal shift. Notice it's -1. Okay, so that means my h is positive. That means I'm shifting to the right 1. Okay, and then on the outside, okay, I've got +6, vertical shift, up 6. Okay, here we go with the little sketch. Okay, some values here: 0, 0, 1, 1. Okay, 4, 2. Okay, there's my original. That's the parent function, and we're going to do each piece. Okay, so on this particular one, okay, you can do the reflection first. Okay, just be very careful. Okay, so you can actually do the vertical reflection later. If you wanted to do these first, go for it. Okay, you're going to move it to the right and then up 6, but you've got to think about what that vertical reflection would look like. You're not going to then reflect like, let's do it. Let me go back. Let's just do the vertical reflection first, and then I'll talk about what I mean in a second. Okay, here we go. There's my square root, right? Same shape. Okay, there it is. I reflected it across the x-axis. Okay, now we can do the horizontal shifting and all that. Okay, so I'm going to go ahead and do this. Right 1. Okay, up 6. So it's really, I shouldn't have done that in blue, but that's just kind of like the halfway point, right? We took care of that. Now we're going to do these two. Okay, so up 1 or over 1, up 6. So there is my completed function. Okay, and I'm going to go ahead and cross that out. Okay, but that is my transformed value. Okay, as long as I'm shifting, as long as that's a unit of 1 and then up 6. Okay, now let's talk about the order of this. Okay, what if I did the horizontal shift right 1 and the vertical shift up 6 first. So I would start here, and it would be like up here, right? The function would be looking like that. But we've got to think about that vertical reflection. You're not then going to do the reflecting across the x-axis here. Like you would be way over here if that was the case. Okay, so you actually want to do the vertical reflection first, and the reason is because we've got to think about order of operations, right? You are multiplying here, so that's kind of the like first thing you do. Okay, you're shifting it, then you reflect across like kind of the new x-axis. That's one way to think about it. Okay, so there we go with our transformation. Okay, now to talk about these. In my opinion, these are a little bit easier. You can kind of, maybe the only hard part is the shape, okay? So you got to know your parent functions very well to name the shape, and then you've got to understand kind of what is literally what's going on to identify the transformations, okay? But if you can do the first one, in my opinion, you should be able to do these as well, okay? Let's go ahead and finish with the domain and range here. All right, so the domain, okay, well, our new one, right, it's starting here, okay, we got to think about what that value is, right, and it's, for my domain, it's 1, right, and we're working with my x, so it's x such that x is, well, greater than 1, or equal to, right, because it's starting here, starting at 1, going on forever. Okay, range. So this one's a little bit weird, okay, but we got to think about where my y is, okay? Now it's going down, right, and it kind of has a max now, okay, right? And in the beginning, right, in the original, in the parent function, it has a minimum, but now it's got a max, okay? So y, it can be anything, but it can't be greater than that value right there, which is, we got to think about what that value is for its y coordinate, and that is going to be 6 because we shifted it up 6. Okay, so we've got that right there, and it peaks at 6. Okay, so that is your range. Okay, it takes practice, right? You've got to. If I were you guys, I'd be all on Desmos, looking at the differences. You know, looking what happens when I change A, looking what happens when I change B, when I change multiple. Okay, it's just it's a very visual thing, and the best way to do these is, in my opinion, is a little bit of exploration, and luckily you have Desmos as a great piece of technology to help you out with that. Okay, those are the notes. And if you have questions, please let me know. I will put the completed notes on Google Classroom.